Hey, IB kids. So we're done with acid rain. We're going to move on to the next part of environmental chemistry. And this doesn't have much to do with acids and bases, but it's part of our little IB part on environmental chemistry. And this section is on the greenhouse gas effect. The greenhouse gas effect is a well-known effect throughout all of physics. This is almost not a chemistry thing, it's a physics thing. And the greenhouse gas effect has been known for more than 100 years. How does the greenhouse gas effect work on Earth? Well, you have the sun. The sun produces energy. And the Earth absorbs the energy. Okay? That's why you and me, the trees and the bees are all alive, is because we absorb energy from the sun, thermal energy, light energy, radio waves, all of that has energy, but most of the energy that's from the sun is thermal energy. Now, the Earth, while it absorbs a lot of energy, the Earth radiates this energy back to space. And the energy that it radiates back to space is a longer wavelength. And what that longer wavelength does is the longer wavelength causes bonds in some molecules to vibrate. And vibrations has energy. Now, molecule by molecule, it means nothing. But the Earth is huge compared to a molecule. So you have billions and billions, trillions of molecules vibrating. And this vibration sends energy back to Earth. So if Earth was to capture all of the energy that we got and not radiate any of it, it would be way hotter than it is right now. So the fact that Earth radiates energy is really important. And if this vibration didn't occur, because Earth bounces back so much energy, Earth would be way colder than what it is. And our atmosphere is just perfect for keeping the right amount of energy that allows us to survive. We've evolved as humans and life on Earth within the energy confines of the Earth. That's the greenhouse gas effect in a nutshell. Energy from outer space hits Earth. Now, that's not like a laser, but this is a good example of it, and bounces off back to space. Our atmosphere, you can't see that with a black pen. Our atmosphere takes some of that energy and bounces it back down to Earth. So this is not necessarily a bad thing. In fact, it's a good thing. Earth is probably outside of the Goldilocks zone without this happening. So a lot of exoplanets that we find, Mars is a good example, because Mars has no atmosphere, it has no greenhouse gas effect, and it's so cold on Mars. Venus is way closer to the sun than us, and Venus has a runaway greenhouse gas effect. Its atmosphere is so full of molecules that bounce energy back, the temperatures on Venus melt lead. We can't actually explore Venus because the pressure and the temperature is so immense because of its choking atmosphere. Okay. So this whole area of greenhouse gas effect is going to be seen through the lens of climate change. And I'm not going to spend a lot of time talking about climate change, aside from the fact that the vast majority of our best scientists who study climate change say that climate change is occurring and it's caused by humans. And yes, you can cherry pick data to show that perhaps the climate is cooling. A good example of what some people do who are not using the best data is they take a look at this warming trend. So this is a UN warming trend graph, and they'll pick like a certain spot in the graph to show that we actually are cooling. Well, true, we cooled over a couple of years, but the trend overall is a rapid increase. And there's also really complicated things at play every year based on ocean currents. They're called El Nino and El Nina. And some of those years are warmer and some of those years are cooler. So you kind of have to look at the average. And that's why you almost need somebody who has a degree in physics to understand the dynamics of the air. Canada has a really famous climate scientist named Professor Catherine Hayhoe, or Dr. Hayhoe. She was actually on my podcast, and she is a really cool person. She talks about climate change all the time, talks about the data, and it's a very touchy subject, right? Like, we live in Alberta, which produces carbon, and carbon when burnt produces carbon dioxide. And why is that such potentially a big problem? Well, we'll get to it. And the other thing is that climate change has now become political. You can almost determine if you believe in climate change or not once you're past about 25 years of age, depending on what party you would vote for. But climate change is a type of science. So scientists, the vast majority of scientists, like a huge percentage, 95, 96, up to 100%, who study it say that it is occurring. So that's the end of that. There are some scary graphs from time to time that get shown. So this is a graph that shows the trends over time. And the last couple years from 2000 is right here to us, right? So we're a little sliver in time. Maybe it's going to go back and do this kind of stuff. That would be awesome. Let's hope the climate scientists are wrong, but the data doesn't show that. So just to finish up this quick little mini lesson, because there's not a lot here, not all molecules absorb energy the same way. And some molecules are not greenhouse gases. Nitrogen and oxygen are not greenhouse gases. So most of our environment that we breathe, nitrogen and oxygen, comprises almost 100% of our atmosphere, doesn't do anything with greenhouse gas physics or chemistry. Symmetrical molecules like nitrogen, and we'll get into the bonding unit later, nitrogen looks like that, and oxygen looks like that. Because they're so symmetrical, they don't have vibrations. They don't have vibrations when the low wavelength energy hits it when it's being re-radiated from Earth. So water is actually a greenhouse gas effect gas, but a very, very, very crappy greenhouse gas. It contributes almost nothing to greenhouse gases. Carbon dioxide, this is the big touchy subject. Carbon dioxide has a factor of heating up the environment 10 times better than water. And because there's so much of it, its contribution to greenhouse gases in the global warming, GW, is 50%. So carbon dioxide is the big gas. Now, methane is way worse than carbon dioxide, and we don't really talk a lot about methane. If you burn methane cleanly, it produces carbon dioxide. But if you let methane escape from the ground, it is way worse at heating up the earth than carbon dioxide. And there are some real concerns that as places around the earth melt, and they are melting, the bogs and the permafrost way up north, that has magnitudes of trapped methane that is escaping now, which is kind of too bad. Also within that, and I don't want to get into it because it's another touchy subject, is there's a percentage of methane that comes from agriculture. But humans do need to eat. And we do need to heat our homes. Like, it's a very complicated topic. Chlorofluorocarbons, and we'll talk about those tomorrow, are way worse than greenhouse gases, like methane and carbon dioxide. They're horrific. And we were just releasing these like tons many years ago, but now hardly any of them are released. Okay, other ones, ozone dinitrogen oxide. So this is smog, right? We talked about smog. And then a really weird gas called sulfur hexafluoride. It's way worse than the other one. So ozone is a really bad greenhouse gas. So carbon dioxide is kind of the boogeyman for things causing global warming, but there's other gases that do the same job. Now, yes, chlorofluorocarbons are horrifically worse than carbon dioxide, but we're not releasing chlorofluorocarbons in the same magnitude as carbon dioxide. Yes, 20,000 times worse, but there's maybe like a trillion times more carbon dioxide being released than chlorofluorocarbons. So, is global warming, climate change happening? Yes, it is. That's what the science says. That's not me trying to indoctrinate you guys at home. I have to teach you what the science says. And if in a decade, if the people who study climate change, like I'm not talking about somebody on YouTube or somebody on Facebook, I'm talking about people who have PhDs in atmospheric science and climate change, that they are studying it and they're saying that it's happening. So it is occurring. And I always like this one, that people are like, well, some scientists don't agree. That's true. That's true. Some scientists don't agree. But the scientists that don't agree are a tiny percentage. So what's more likely? That somehow almost all of the world's scientists are in a massive conspiracy to convince people that climate change is happening, or the companies that are potentially at risk of losing money and maybe getting sued in the future with their incredible wealth are spending money to get some scientists to say some things. And the same thing happened with the cars in the 60s and 70s. They put lead into gasoline, and it was poisoning everybody in North America. And the car companies hired a scientist to say, there's nothing wrong with lead. There's nothing wrong with lead. Lead has always been in people's blood. And it took another scientist, Dr. Claire Patterson, to fight them and then gather enough scientists to become a consensus to show that lead is kind of bad to breathe in from car exhaust. And you might see that when you fill up unleaded gasoline. That's from that environmental scientist. So what are some of the most likely effects of global warming? And I'm not going to give you the stupid, what's his name, Al Gore take, because Al Gore had a video that was way too sensationalized and he used the worst projections. These are the most likely effects of global warming. Is agriculture is going to change, and in some places not be viable. So how many years away is this? This is a long time away. So when climate change scientists give projections, they give a range. And they're like worst case scenario, best case scenario, or most likely scenario, and then least likely scenario. The most likely scenario is if nothing changes in the world and we continue moving and using and producing as much carbon as we are, that we're looking at 2050 for these things to start happening. But everything I'm talking about right now is happening right as we speak. So how will agriculture change? Well, you'll have places like Canada, Alberta, have a longer growing season. So it will be potentially better. Climate change will be potentially better for Alberta, agriculture-wise. But you'll have places near the equator, which within 50 years, it will be so dry and so hot, not only will it be very uncomfortable to live there, you're not going to be able to grow stuff. So that's going to be a big change in the world. Biodistribution means that animals will move away from heat. We're already seeing that in Canada. Animals that never used to live in Canada have moved to Canada. Only a couple degrees change depending on the season can move animals around the world. And then that's a big potential problem because you have things that you live in, near the equator or in the United States, moving up to Canada. We don't know how they're going to interact with our environment. And the ice caps will start to, I'm not going to say will start to melt. The ice caps are melting and the sea is rising. It's not like New York City is going to be swallowed up in 5 years, but you're going to have a tremendous amount of sea rise all over the world. And most of the population lives on the ocean because that's where people landed and it was way easier to move goods. Another scientist I had on my podcast, he is a glaciologist. He studies glaciers. He's been and he's walked on the glaciers of Greenland. And the amount of ice that is being lost on Greenland is astronomical. We're talking like Olympic-sized swimming pools, thousands of them a day. And that adds up over time. So again, we're looking at like 2050 to 20, like the time frame for this is so long. It's really tough for humans to plan, especially when people who are in like my age, I'm going to be dead. I'll be dead by the time the worst parts of this occur. So it's really hard for some people to wrap their head around that when they're going to be dead and gone when the problems are going to happen. Or they'll say, you have no way to prove that will happen because it's so far in the future. All right. So it's a very slow process. So a couple things hopefully you got away. This is kind of a rambly video. A couple things hopefully you got from this video was that carbon dioxide is by far the worst greenhouse gas, but that's because of the volume it's being produced. There are other greenhouse gases that are far worse than carbon dioxide, like chlorofluorocarbons. Okay, that's this video.